Hello everyone. What I got here right now is something I learned about the Opera ESCs that I don't think we all know about, the new version 2 ones anyway. What I have right here is a digital servo tester. Okay. Oh, and excuse the bench. I'm not cleaning this mess up until I get all this work out of here. But anyway, so what the digital servo tester does here is, what you see right now is the actual PWM value. So this is exactly what you would see if you went into Mission Planner and your throttle was all the way down and it was adjusted to show 800. You know, it was 800 is too low. Most everyone's throttle is like what, around 1050 or something like that. So when you start coming up with this, I'm testing this one right here. Look what happens with the LED. So if I get down to around 800 and I start coming up, the LED comes on at around 880, 885, 890. So, you know, somewhere around 890 to 900 PWM. So if your throttle, whenever you set up your radio system, if you go into Mission Planner and you get your throttle set, and you're going to have to lower fail-safe throttle value also. And I don't know how this is going to work, but if this is theory, if we lower the fail-safe value to 850 and we lower our minimum throttle down to around 8, well, I think we'd have to lower our fail-safe throttle value down to like around 800 and then have our minimum throttle at around 920. And what would happen is whenever we power up, when we start bringing the throttle up, as soon as it gets up to this value around here is when your LEDs are going to come on. So it's going to work more like Walkera, and that's what this chip is right here. That's what this chip's doing. This chip is looking at the actual PWM value range, and it is what is switching. It's this chip right here. Your PWM value is coming into this plug here, and then this is looking at that before it sends it to the APM chip that spins the motor. So when it sees your PWM value get up to that value is when it turns the LEDs on. Of course, all the output pins are going through the LED power section right here. These 3 resistors right here and these 3 jumpers are your LED colors, and the resistors are for to not burn out the LEDs. But I just figured I'd mention that. These things were calibrated. Let's see. It may not. I may have to power cycle it because they disarmed on me. But these things are actually calibrated with the Walkera transmitter, so they're calibrated from 1050 or so up. And well, the calibration isn't right, so that's why it's not. There it goes. Now it should spin up. It has to be armed. I just figured, okay, so if you turn it down, it's going to disarm, and that's what just happened. To arm it, you go maximum, and you come back down to a safe level with the light on, and it arms. Then you can spin it up. That's what this direct servo does. Your flight controller is going to tell it when you're ready to arm. See, it just disarmed. To arm it, go up, beep, come back down, arms it. There we go. Maximum throttle is going to blink. That's normal. It's a range. You're over PWM. That's normal. 18 something is where normal PWM value is at the high end. So these ESCs function exactly how they're supposed to, and they're awesome. Also take notice of how I'm setting up this Pixhawk with the room I have and how I'm doing the power module right here. This is the APM power module. They make a mini version of this, and they also make a miniature 33 by 33 millimeter power distribution board that has this built on it. They also have one that has 2 of these built on it in case you need to power multiple stuff. But the Mini would probably go well right here. What I had to do is relocate the capacitor and then I direct soldered the positive and the negative with a bus rail basically to the contact. So coming in with your battery lead comes into the module on positive side, on negative side, and the negative is all the same, so it doesn't matter about this side over here. But on the positive side, even if this wire was to get frayed and short, which it's not, because I'm going to take it off and I'm going to put some heat shrink over it up to right here, and then I'm going to hot glue all of this right here and use a hot molding process I do. That can be removed later if you know what you're doing. So that'll keep all this power protected and keep these wires from doing anything stupid. But the lid will go on. I had to move it back. I had to locate the cap so this could go there and move it back. And then I just have to make a short jump lead from here, which is going to go down, come over here and plug into this port. The rest of the stuff I'm working on, so this is where we're at with that. The lead is just long enough to get to. Of course, we're using XT60s. That's where we're at with that. Thanks for watching.